Hey class, today we are going to do Module 5, Lesson 18, and in that we're going to compare the size of fractions. We're going to reason about the size of fractions based on the distance a fraction is away from zero. So if you think of zero as sort of like the starting line, we're looking at which fraction is furthest away from the starting line being the bigger fraction, and which one is closest to the starting line being the smaller fraction. And so we'll do that with fractions that have like denominators, meaning like 1/4 compared to 1/3. We also will do that a little bit with fractions that have unlike denominators, for example, fourths and halves. So 2 and 4 there in the denominator. So I have the problem set here with me, and let's take a look and go over it. All right. So what we're going to do here is we're going to compare the fractions that are over here. So 1/4 and 3/4 in this case, the ones I just mentioned. And we're going to circle the one that's closer to zero. You can see that's already done. And then after we've done that, the one that's closer to zero is the smaller one. So like you could think of this as, again, traveling from a starting line. So like this runner here has only gone this far versus the runner that went to 3/4, which went that far. You can see that second runner has gone further, so it's covered a longer distance. When we're measuring on a number line, that's really kind of what we're doing, is we're measuring distance from zero. And in this case, the 1/4 has not gone nearly as far on that number line as 3/4 has. So it is smaller, and we can put a less than sign in there. Let's go ahead and take a look at the next one. It's 2/6 and 3/6. So you'll notice that this number line is blank, first of all. And so we need to fill it in. And this is good practice. So anytime I have 6, I first split into thirds and then take each third and cut it in half. So I have 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. And so then I need to go ahead and find 2/6 and 3/6. So 2/6 is here and 3/6 is there. So I'm going to compare which one is further from this point. Well, it's a shorter distance to 2/6 than it is to 3/6. So 2/6 is smaller than 3/6, which means, again, 2/6 is less than 3/6. So the one that's closer to zero is the smaller fraction. Let's take a look at the next example. This one has mixed denominators. So we have 1/2 compared to 1/4. So this is going to involve a little bit of creativity on our part here. Let's first split this into half. So the first thing I'm going to do is put that. I'm going to label that down here, 1/2. And then I'll label this 0/2 and this 2/2. 2/2 equals 1. Okay. Now on the top of the line, I'm going to label 1/4. When we get more like experience with this, we can label them all down here. But just for the sake of this problem, I'm going to label the fourths up top. So we have 0/4, and then halfway through is 2/4. We split the halfway between 0 and 2/4 is 1/4, and halfway between 2/4 and 4/4 is 3/4. Okay, so I have 4 equal parts here for fourths and 2 equal parts here for halves. Well, 1/2 is there and 1/4 is here. Which one is closer to 0? And the one that's closer to 0 is 1/4. We've only gone this far versus that far. So 1/4 is less than 1/2. So in this instance, we'd say 1/2 is greater than 1/4. That one's a little bit trickier, right? The other ones we're pretty familiar with, like the one in number 2 here, where they're common denominators, meaning they're all the same, and we sort of know if they're the same denominator, the lower the number on the numerator, the smaller the fraction. We're pretty familiar with that. What we're not familiar with yet is this thing we just did, where we compare fractions that have uncommon or not the same denominators. We have another chance to look at that here with 2/3 versus 2/6. So 2/3, let's do that first. I've split my bar into here, I'm even going to label this. Look. That's a third. That's a third. That's a third. All right. Now let's split it into sixths. I know 6 is 2 times 3, so I can take each of my 3 parts and cut it in half again. And look, I made 1, 2, 3, 4, 5, 6 spots. I'm gonna, on the top, shade those in or color those so we can identify them easily. All right. So as you can see on the bottom, I have 3 sections in pink, right? And on the top, I have 6 sections in orange. So 2/3 that line and that line, they're my pink sections. 2/3 goes there. 1/3 goes here. 0/3 and 3/3. Right? You see how 2/3 lines up with having 1 pink section, 2 pink sections. Once I've done 2 pink sections, I am at 2/3. Now I'm going to look at my orange sections and I'm going to 2, 6. So 0, 6, 1, 6, 2, 6. So I've had 1 orange section, 2 orange sections. I stop right there. I'll label these though. 4, 6, 5, 6, 6, 6. That's good practice for you to label the number lines. So I'm comparing this. Oh, I shouldn't circle that one. Sorry. I should have circled the 1/4 up there. I should look at this point right here. We can see that 2/3 is actually equal to 4/6. 2/3 and 4/6 is the same thing. If I take 2 and divide it, 4 divided by 2, I get 2. If I take 6 and divide it by 2, I get 3. So that means they're equal. 2/6 is right here. And this is a smaller one because it is closer to 0 than 2/3. So 2/3 is greater than 2/6. Some of you may remember that I said when we have the same numerator, we can look at the denominators, and the bigger the denominator, the smaller the fraction. We talked about that with unit fractions. That's true anytime you have the same numerator. So in this case, we have 2 in the numerator, so all we really had to do is look at the denominator and see that 6 is larger, which means we have 2 pieces, but they're smaller pieces because it's been split 6 times versus 3. So it seems kind of like this is new stuff, but at the same time, a lot of the themes and the ideas that we're talking about are things that we have already discussed. We're just applying them in different ways. This last one, we're going greater. You can see we start at 1 and we go to 2. So our fractions are greater than 1. Keep in mind that 0 is back here on the number line somewhere. So when we're talking about closer to 0, we just mean further left on the number line in this case, because we're working with positive numbers. So let's split it into fourths first and then into eighths. So 1 to 2. So split into 4 parts. I can do this. And again, I'll color code them for you to show you that there are 4 sections there in orange. And this is 4/4 equals 1, 5/4, 6/4, 7/4, and 8/4. Okay. And now eighths are twice as small as fourths, which means I have to take each fourth and divide it in half again. And you can see that I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 sections in pink there. So this is 8/8 equals 1, 9/8, 10/8, 11/8, 12/8, 13/8, 14/8, 15/8, and 16/8. Now I can again check 16/8 to make sure it's true. I can go 2, my whole number, times 8, the denominator is 16, and it does line up. That does work. So I'm comparing 7/4 right there and 11/8 right here. 11/8 is further left on my number line than is 7/4, which coincidentally is the same as 14/8. So 11/8 is smaller or less than 7/4. Again, when you're working with positive numbers, the further left on the number line, the closer it is to 0, the smaller it is. Okay, let's take a look at the back. Joanne and Lupe live straight down the street from their school. So that means it's a straight line. We're not taking any turns or anything. Joanne walks 5/6 miles and Lupe walks 7/8 mile home from school every day. Draw a number line to model how far each girl walks. Who walks the least? Explain how you know using pictures, numbers, and words. So just a couple of different ways you could approach this. You could either put this on one number line or two. Putting 6 and 8s on the same number line is certainly possible, but it might be tricky for you to line them up properly. So here's what I sometimes recommend doing. Sometimes I will draw two like connected number lines. That way I know that they're exactly the same size, right? They're the same length. And I'm going to compare this number line to that number line. This is a good way to get used to doing denominators that are not the same. So we know 0 miles, I'm going to label it top and bottom, and 1 mile. Okay. And so on the top one, this is Joanne and this is Lupe. So Joanne is walking in 1/6 of a mile. So I'm going to take this and split it into 6 parts. Okay. The other way I could have done this is on the same number line, like in different colors or something like that. That could have helped us too. Whereas Lupe is working in 1/8. Okay. So we have Lupe going 7/8, which is 1, 2, 3. Let's just label them 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and 7/8. And 1 would be 8/8. 1 equals 8/8. So Lupe lives this far from the school, right? 7/8 of a mile. Whereas Joanne lives 5/6 of a mile. So this is 1, 6, 2, 6, 3. Notice 3, 6, and 4/8. See how those connect? Those are the same. They're both equal to 1/2. 4, 6, and 5, 6. Well, if I drew a straight line down here, it looks to me that 5/6 is less than 7/8. 5/6 is a bit smaller than 7/8. So 5/6 is less than 7/8. Not by much, they're pretty close. So this is a way that you can draw them on 2 separate number lines, but making sure that those number lines are the same size by like sort of connecting on the endpoints there like I did, and stacking them vertically on top of each other and being able to compare in that way. It's a little bit tricky, I'll be honest, because if for example I didn't measure right and I put 5/6 over here, or I put 7/8 over here, like comparing fractions that are close to each other on a number line can be really hard to do accurately if you are not really careful about where you're putting your numbers on the number line. And as you know, that can be a struggle for me, and I know it can be a struggle for you sometimes too. All right, this one says, this will be the last one that we'll do here. We'll do number 7. It says Cheryl cuts 2 pieces of thread. The blue thread is 5/4 meters long. The red thread is 4/5 meters long. Draw a number line model, et cetera, et cetera, et cetera, to show which piece is shorter. Now, I can automatically look at those and answer this question, and so can you. Take a minute and think about that as I set up our number lines here. I'm going to do the same thing. I'm going to draw 2 of them. And I know one of mine here is greater than 1. So I'm actually going to put a line in here. So this is going to be 0. That's going to be 1. That's going to be 2. Because 5/4 is greater than 1, because the numerator is bigger than the denominator. So we need to pay attention to that. We need to make both number lines go that far. So here we go. We'll do 5/4 first. So this is we took that first number and cut it into into 4 parts. So 1/4, 2/4, 3/4. This is 4/4. And then we have to go over here and make 5/4, 6/4, 7/4, and 8/4. And the point we're looking for is that point right there, 5/4. And then on the other one, we're going to split it into fifths. So 1, 2, 3. I draw 4 lines to make 5 parts. And I could do the same thing here. And then I have 1/5, 2/5, 3/5, 4/5, 5/5. I'm actually going to stop there because the point I'm looking for is 4/5. I actually don't need to fill in the rest on this bottom one. And so we're comparing 5/4 to 4/5. And the bigger number, the larger number is 5/4 because it's further away from 0 and it's greater than 1. This one here is 4/5. It's less than 1. It's closer to 0. So 4/5 is less than 5/4. Right. And that when I said that you could answer this already without even drawing this, what I meant is that you should be able to see that the numerator being bigger than the denominator shows us that that fraction is greater than 1 whole. So she has more than 1 meter here. And this one, because the numerator is smaller than the denominator, means that it's less than 1 whole. So that automatically means that piece is smaller than the piece that's longer than 1 whole meter. So that's a good way to always double check, like right away, check your numbers and see, like, is there something obvious in this problem that I can already sort of figure out before I even draw my number lines. It's a good idea to still draw the number lines and prove your point and show your work. But sometimes you can go into the problem saying, I already know what the outcome is going to be, or at least I have a really good idea of what the outcome is going to be, and let me just go ahead and prove it now. So you guys have been working really hard on this placing fractions on a number line. I recognize that it's not an easy task for third graders. I know that it can be quite challenging, and let's keep working through it together because you guys have made great progress, but I know you also still have a lot of questions. So we'll take our time and we will learn as many strategies as we can to help you out as we move through this unit.